All right, let's move on to the next indeterminate form strategy, which is to simplify complex fractions. So as always, we would start this limit problem by doing direct substitution, plugging one in, seeing what we get. And 1 minus 1 is 0, and then 1 minus 1 over 1 is also 0. So again, we have an indeterminate form. We couldn't factor and cancel because the thing on the bottom isn't a polynomial. And we can't do rationalization because there's no radicals on top or bottom. So now we're going to talk about a new strategy, which happens when you have complex fractions, which are fractions with fractions inside of them. So the way you do that is you simplify those fractions. So what I'm going to do is I'm going to look inside this fraction and look at any fractions that I have. I only have one fraction in a fraction. That's this, 1 minus x. So what I'm going to do is if I had multiple fractions, I would think about a common denominator between those fractions. But since I only have one, I'm going to simplify this. And there's a couple of ways of doing this. I think the easiest way is to multiply this fraction by a special form of 1, kind of like we did with the rationalization. But this time, instead of the thing being conjugate on top and bottom, this is going to be the common denominator on top and bottom. So the only denominator I had inside the complex fraction was x. So I'm going to multiply the top and bottom of this thing by x. Now, when I do that, on top, I would have x times x minus 1. And on bottom, I would have x times x minus 1 over x. Now, remember the thing we talked about in the last two strategies, when we plugged in 1 in the original and got 0 over 0, we expect to get an x minus 1 like you cancel on top and bottom. So on top, we do not want to multiply that out because that x minus 1 is already separated. On bottom, we are going to multiply it out. So now you can see the thing at the bottom is a factorable polynomial. And now I can use my factor and cancel strategy and do a direct substitution after I've canceled my offending factor. So whenever you have a complex fraction, which is a fraction inside of a fraction, look at the denominators of the inside fractions, the ones that are inside the complex fraction. Get a common denominator if necessary, then multiply top and bottom to get rid of that, and then follow any strategy that you have that emerges.